Hello students, I welcome you in the part 16 of this ongoing video series of transition metals, that is D and F block elements, and we are discussing now about their color properties. Okay, the first fact is that most of the transition elements or metals, ions, uh, exhibit color properties. In most of the cases. Okay, now this is why they show this color property. So we can say this is due to DD transition. This is due to DD transition of unpaired electrons in their T to Z and EG D subcells. Okay, so due to the DD transition from lower level to if I draw the diagram here, say it is the splitted D subcell, where this lower level is T2G, this higher level is EG. Now if electron is there in this and go transfer to there, in this process it absorbs some energy, and when it come back, this is now excited state, and this is its ground state. Now the same electron when come back to its ground state, the energy absorbed earlier, that is H nu, that will be liberated again, and in this DD transition process the color is shown. Okay, and now the next we'll see next point, they require less energy in this DD transition in this DD transition. If you see, they require less energy in this DD transition. That's why use what? That's why they use visible spectrum. Visible spectrum of sunlight, that is any of these Vibgors, and that's why emit they emit color, because only the wavelength in the visible region have tendency to emit colors. For example, scandium 2 plus, titanium 2 plus and vanadium 2 plus, they show color. Why? Because scandium 2 plus contain 3d 1 electron, and this titanium 2 plus contain 3d 2 electron, and vanadium 2 plus contain 3d 3 valence electrons. Now these electrons when jump from lower to higher orbits, and then in higher energy level, and in this process they first absorb, then emit light, and this is the reason for their color showing. And similarly, some other examples, okay, where there are no unpaired electron, where there are no unpaired electron, where there is no unpaired electrons available, no color is there. Okay, for example, if you see scandium 3 plus, then thereafter titanium 4 plus, then you see copper plus, then you see zinc 2 plus, etc. Now in all of these, if we see, scandium content 3d0, no electron at all. Titanium also contain 3d0, 3d0, so no electron is available there. In copper plus we have 3d10, and in zinc 2 plus of course we also have 3d10. So that's why they are less, they are colorless due to this region. Now see how they exhibit color. So there is some diagram. Here is this is the electronic configuration 3d1. Now this electron when absorb light, say this is the degenerate cell. Now here after degeneracy is broken, that is splitted, it is T2G and it is EG. Now this one electron from T2G level when absorb light from the visible spectrum, say VIB, GY, OR. Now among these, suppose this particular compound absorb green color, so the light reflected there will contain only VIBOR without G. That's why it will emit complementary color of G. Now this complementary color of G is what? After